there, Funky Coder, it's Prof G, and it's time to break out the electric bass and cue up the horns, because we're going to learn about functions in Swift. And as an added bonus, we'll also learn the guard statement, and we'll use a switch case statement with ranges. Let's get funky. So in our last lesson, we got our You Are Awesome app playing random cheering sounds in addition to our random inspiring messages and inspirational images.
Yay!
But now we're going to tackle functions for writing better, more efficient, and more maintainable code. And while we're going to write functions in our You Are Awesome app, let's first create a new playground so we can experiment with functions, and I'm going to save my playground with the name Functions. Now, functions are reusable chunks of code that perform a particular task. There are also functions that are built into particular types. These are referred to as methods. So methods are functions that are part of types, whether it's the standard Swift types like strings or arrays, or any of the structs or classes that Apple gives us, and we'll eventually be writing our own structs or classes, so our own types, and those can have methods too. And as an example, when we use dot notation to access code that ran on a value like dot append or dot remove, those were methods, special functions that run on the array type. So you'll often hear the word method and function used interchangeably, but technically a method is always a function, but not all functions are methods, since it's possible to write a function that's not attached to a type. If it's helpful, you might even think of functions as being the verbs of programming. Append, remove. Now, why do we use functions? They are hugely helpful. Functions are one of the most important concepts in computer science, and most computing languages support some kind of functions. They help us organize our code. They help us reuse code so that we don't have to write as much code. And also, when you're not repeating code in different places, there's less of a chance that you'll make errors. Functions can make our code smaller and more efficient, and they make our code easier to maintain. So this is how you write a function. Use the keyword func, F-U-N-C, and give this a one-word name. The standard for functions like variables is lower camel case, and a good function name describes what it's doing, like play sound or calculate average. Then the name you give a function when you define it is always followed by two parentheses. Now, at a minimum, a function has empty parentheses. We'll eventually learn that you can also pass values into a function, and if you do, we'll put parameters and types in between the parentheses. We'll also learn that you can return values too, but that's not a requirement for all functions. Then the statements that we execute each time we call a function are inside of the function's curlies. Now, how do you call a function once you define it? Just use the function's name. No keyword func, that's only for the definition, and if there are any parameters to pass in, Xcode will tell you via code completion. So let's write our first function. So our first function will roll a 6-sided dice and print out the results. Super simple. There'll be no parameters and no return value. So to define the function, we use the keyword func, then give it a name, lower camel case. Roll dice is a good name. We're going to pass nothing in here, so it's just open and close parens, but even if a function accepts no inputs, it's still got open and close parens after it. Then open and close curlies, and inside we write whatever code we want the function to run whenever it's called, and that's just going to be print, you rolled a string interp, and this will be int.random in from 1 ... to 6 closed range. And now let's call this 3 times. So down below, we'll enter roll, and look, code completion knows roll dice was just defined. There's a little F to the left, so that shows that it's a function. So we'll put this in 3 times, roll dice, roll dice, roll dice, shift return, and we see the function has run 3 times. So instead of having to write this code 3 times, we just write the code once and we call it 3 times. Now let's imagine we make a mistake, or our client comes back to us and says, hey, instead of a 6-sided dice, this needs to be a 10-sided dice. Well, we just make the change in one place instead of 3, and now it's available everywhere we call the function, so we run this again, and we get 3 rolls of a 10-sided dice. So shorter code, we reused our code, easier to maintain, faster to write, you're seeing the benefits of functions. So now let's return to the game of my youth, Dungeons & Dragons, which, as we mentioned in an earlier lesson, is played with various multi-sided dice. Now, instead of writing a separate function for each type of dice, 4-sided, 6-sided, 8-sided, 10-sided, 12-sided, and 20-sided, we can instead write one function with a parameter that accepts the number of sides on a particular die, and we can use that number as the upper bound in the range that determines the random number in the dice roll. Now first I'm going to print out an empty string so that I advanced one line. Then we use our keyword func. Why don't we call this function roll-sided dice? We're going to pass in one parameter between the parens. Why don't we call this dice sides, colon, that's going to be an int. Open and close curlies, and on the inside we'll write print. You rolled a string interp on a string interp sided dice. The first string interp is going to be int.random in 1 ... dice sides, and the second string interp is just going to be dice sides. Then let's roll this bad boy a few times. Roll-sided dice, we see code completion has got this. Press return. It's waiting for an input, so first we'll roll a 4-sided dice. Then we'll do the same for a 6-sided, 12-sided, and 20-sided dice. Shift return. And look at this. We'll just expand the screen. We can see we got our 4 dice rolls down here. Swifter, you just wrote a 1-parameter function. Nice. Well, Swifter, I bet you could write a 2-parameter function on your own. So here's your challenge, the 2-parameter multiple dice roll. What you should do is simulate the rolling of several dice, all of a given number of sides. For example, 4 8-sided dice. We're going to call the function roll several dice. It'll accept 2 parameters, number of dice, which is an int, and dice sides, also an int. And an example of the output for rolling 2 10-sided dice would be rolling 2 10-sided dice, and then the results of each roll, 8 and 4 in this particular case. So give it a try, pause, I bet you can do it, and when you're ready, resume, and let's compare answers. So this is going to be a function with multiple parameters. I'll print an empty string again just to give myself another line feed in the console, and we're going to call this func roll several dice, and in between the parentheses we're going to put 2 parameters. The first one's going to be number of dice int, and then to separate the different parameters we just put in a comma. Then the second parameter, dice sides int, open and close curlies, and our function's first line is going to be a print statement. We're going to say print rolling string interp, comma, string interp dash sided dice. And in that first string interp, we're going to put in number of dice. And notice, since number of dice was a parameter we defined as part of our function declaration, code completion will know about any parameters we defined as part of the function, and it will suggest those inside that function's curlies. Any of those parameters passed in the function have scope inside the curlies. They don't exist outside the curlies, but they are available inside the function. And in the second string interp, we're going to put in dice sides. Once again, Xcode knows this exists. Another thing to notice, you see the L next to dice sides? That points out that dice sides is a constant. Now that was the case for number of dice too, and it's the equivalent for any parameter that you pass into a function. You can think of the L as being the equivalent of using the let keyword to define a value. Now that's important to know because the parameters that you pass into a function like this cannot be modified inside the function. They're treated like they were defined with a let. They're constants, they can't be changed. So I'll press return to add dice sides in here. Now we want to roll our dice a certain number of times, and we know that if you want to perform a task a certain number of times, we can call upon our friend, the for statement. So we'll say for, I'll call the current iteration I in 1 ... number of dice. Now we're going to return to take a look at that I because we're actually not going to use it between the curlies. Let's open and close curlies, and then we'll say print int.random in 1 ... dice sides. Then down below, let's call this function, and ho! When I type roll, I see code completion has all 3 roll functions that we defined. The last one is the one that we just did, roll several dice with 2 parameters. Select that one, then press return. Code completion sets me up to enter the 2 parameters. Why don't we put in a 3 for the number of dice and 10 for our dice sides. Shift return, rolling 3 10-sided dice, and we get our output of that roll. Nice work. Now take a look back in our code. We have a warning. Now this isn't a crash for our code, it's just an Xcode suggestion. Remember I said we were going to come and take a look at the I again? We didn't use it in between the curlies. So we go through the numbers 1 through number of dice, but we never use the I value that we've created here. So Xcode tells us immutable value I was never used. Consider replacing it with an underscore or removing it. Up until now, we've always been using this index value inside of our for loop, but here we don't even use it. We just go through the for loop 1 to number of dice times. So Xcode is saying, hey, you don't need the I in there. You're creating a constant each time you go through and you're not using it. So if I click on the little yield sign, Xcode offers to fix this. I can click on the fix button and we can see it puts an underscore in there. If I click the stop and play button just above the console, the code still works as normal. We're not going to see a massive improvement in the performance of this code, but we don't have an extra value I that we're not using. Now here's another challenge. It doesn't involve changing the function call, but this is a good check to make sure that you're understanding how to write basic Swift code. Try both parts of this challenge. If you can only get one, that's okay. We'll show a solution in just a bit. First, can you modify the roll several dice function so that after all of the rolls print out, the function next prints total roll, total, where total is the total of all rolls made by the function? Then next, can you modify that same function so that it prints the dice rolls on a single line instead of on separate lines? So the complete output of a function call to say, roll 4 6-sided dice might look like this. See how the 4 individual dice rolls, 4, 1, 3, and 5 are all on one line? So give this a shot, pause, try your best. If you can only get one part, that's okay. And when you're ready, resume, and let's compare answers. So first I want to highlight and copy the last function. I'm going to use this as a template, and then I'm going to command / to comment it out. Then below I'll write a comment, total dice roll challenge, and I'll paste in the code that I just copied. Now, totaling up the number of dice is fairly straightforward. Hopefully you thought so too. So first we need to create a variable to hold the dice roll total. So let's create this right after the function declaration, just inside the curlies, and we'll call the value to hold the total total. So how about var total equals 0? So when we start out, we have no total, we haven't rolled any dice yet. Now we'll want to change what happens inside the curlies of the for loop. And what I'm going to want to do in there is, after I roll the dice, I'm going to want to both print that dice roll and add that value to my total. So in order to do this, I'm going to create a separate value to hold my dice roll. Then I can use this both in the print statement and I can add it to the total. So right under the curlies of the for loop, I'm going to create a new constant. I'll say let dice roll equals, and I'll cut the int random code that rolls the dice and I'll paste it after equal. So each time I go through the for loop, I'm going to roll the dice again, and that new roll is going to be in dice roll. Now in my print statement, I'm going to print out the dice roll, but I also need to add dice roll to my total value. Now I could do that before or after the print statement. I'll do it before, and I'll write total equals total plus dice roll, or you could use the shorthand total plus equals dice roll. Then after the for loop, we have our total, we've rolled our dice, and each time we've rolled the dice, we've also added that number to total. So just before leaving the function, we're going to print the total. Just before the function's closing curly, add print, and in quotes, total roll, colon, string interp, and in between the string interp, we're just going to pass in total. And now if we call this with 3 dice at 10 sides, if I shift return, we see the roll shows up, proper total, perfect. I'm going to change my function call to 4 6-sided dice, run the code again, and this works great. First challenge solved. So if you didn't get this the first time, you can stop the code, solve the challenge, and keep doing that until you've really got this down. You can also wait until the next day or the day after, but you really want to make sure that you understand how to solve a challenge like this as we move forward in our class, because things are going to get more challenging from here on out. Now, while I guess most of you got the last challenge, this next challenge isn't something that we've done before, so don't feel bad if this was a struggle. The way a lot of programming challenges work is you might not get the challenge the first time because you've never seen that pattern or technique used before, but after you've seen a solution, you should be able to go back a second time and complete that challenge. And you should understand the solution enough so that you would be able to complete similar challenges too. Now, there are a lot of different ways that we could solve this last challenge to print all of the rolls on a single line separated by commas, and I'll show you one solution that uses techniques that we've already covered in our prior lessons. Now, we haven't done much with building up strings, so if you missed this the first time through, don't feel bad. But if you didn't get this, do go back and make sure that you can complete the challenge on your own after you've seen the solution. So like before, I'm going to highlight the last solution, I'm going to copy it, then comment it out. Then down below, I'm going to write the comment, all rolls on one line challenge. I'm going to paste the code that I just copied. So if you were trying to solve this and you were wondering, how do I print a string as we go through the loop without adding a carriage return after each time I print it? Well, the answer is we don't. Instead, we're going to build up a string each time we go through or pass through the loop, sort of like the way that we add values to a total. So we're going to start with an empty string, and with each pass through the loop, we're going to add our roll number to the end of the string. Then just before we print out our total, we're going to print out that string that we built up with all the numbers in it. So first we need to create a variable to hold the string that contains all of our roll values. And this should initially be an empty string, sort of like our total is initially a 0. So I'm going to call this string roll string, and I'm going to declare it and initialize it just below our total. So we'll say right here, var roll string equals empty string. Then the trickiest part is handling the comma and the space in between the roll values. So every roll has a comma and space in front of it, except for that first roll. So what I'm going to do in this solution is before we go through our for loop, we're going to roll the dice, we're going to add that roll to total, and we're going to add that value to our empty string too. Then instead of going through the range from 1 to number of dice, we're going to go through the range from 2 through number of dice. Then inside the for loop, we're going to add a comma and a space to the roll string before we add our dice roll. So let's try this out. So before we reach the for loop, we're going to say total equals, and it'll just equal our first dice roll. So I'm going to copy this int random code from down here to get a dice roll. I'm going to paste it in after the equal sign. And since this is our first dice roll, total equals the first dice roll. So below this, I'm going to set our roll string equal to that total. Again, that's our first dice roll. So I'll say roll string equals, and in quotes, string interp, and in between the parentheses, I'm going to pass in total. First roll added to the total and to our roll string. Now let's change our loop. Now since we've already rolled once, we don't want to go through a range from 1 to number of dice. We want to go through from 2 through number of dice, but we only want to do this if the number of dice that we're rolling is greater than 1. If it's not, then the function must have been called with only 1 dice roll, so we should just print the 1 dice roll that we've got and be done. So before the for loop, I'm going to add an if statement. I'm going to say if number of dice is greater than 1, and then I'm going to add a close curly for the if statement just before the print statement. But oops, I forgot my open curly after the if statement. and my indentation is all off. So this is a perfect example of when I'd want to use our keyboard shortcut Command A to select all and Control I to fix indentation. And there, after this, everything looks good now. So hopefully you see what we're doing here. No loop unless we have number of dice greater than 1. And if that's the case, well then we need to start our for loop range at 2 instead of 1. So I've changed that. And then instead of printing dice roll inside the for loop, I'm going to instead build up our roll string by saying roll string equals roll string plus, and in between quotes, I'm going to say comma, space, and then string interp. And I'm going to pass dice roll in between the string interp parens. So for the first roll, we don't have a comma and space character, but just before every additional dice roll, we first add a comma and space character to the roll string before we add our dice roll. Then just before we print out our total, we'll print out our roll string with print in parentheses roll string. Then let's shift return and try this out. And will you look at that? All 4 rolls are on one line with commas separating the values. Nice! Then I'll change this call to 5 10-sided dice, run the code again. Looks good. And now let's do some quality assurance. So I wonder what happens if I pass in 0 10-sided dice. And oh no, it calculates a single dice roll, not what I want. So let's code a bit of error handling so that if a user enters a number of dice less than 1, we'll instead tell them that that's not a valid number of dice. And along the way, we can also take this opportunity to learn about the guard statement, which is very similar to guard let, which we saw in our lesson on playing sounds. Now first we'll prevent the error with an if-else statement since we know how to do that, and then we'll swap that out for the guard statement, which is a bit cleaner and more efficient. So just after the function declaration, let's write if number of dice less than 1, open and close curlies, else, open curlies, and we'll add the close curly for the else just before the close curly for the function since we don't want to run the code that prints the totals here. Then we'll go back to the if curlies, and if the statement is true, then we want to print out, how about, cannot calculate roll of string interp dice, and we'll pass in number of dice into the string interp. Then if we run this code, passing in 0 for the number of dice, we get our error message, cool, but if we change this to 1, we get a single dice roll, error prevented, good work. But now let's see how we can do this with a guard statement instead of the if statement, and why this might be a better choice. So I'll write the guard statement this way. We'll do it just before the if-else statement, then we'll go back and we'll delete the if statement. So I'm going to write guard, number of dice greater than 0, else, open and close curlies. So this is the statement we're guarding for, number of dice greater than 0. So the guard will let us through if this is true. If we don't meet this condition, then we're going to enter the else clause between the curlies. Now we have to put in a statement that exits the function. We'll use the return statement to accomplish this. And just before we hit return and quit the function, I'm going to copy our error statement from down here. I'm going to paste it in front of the return so that the user sees this error warning before we quit the function. So if number of dice is not greater than 1, then the guard is going to kick us out of the function. It executes the else clause, it prints the error, and return means we don't execute any more code and roll several dice. But if we pass the guard statement, we have a value that's greater than 0, then we continue to run the code below this guard statement. We don't execute anything in between the else curlies. Now what's the benefit of this? Slightly less code, and we don't have the indent that we have with the else statement and the if-else statement. So since the guard does all we want, we can delete the if-else up here, and we also need to get rid of the last curly that's just before the close curly in the function. And I need to fix my indents again, so again, Command A to select all, Control I to fix indents. Looking good. And now I'm going to get rid of a bunch of these blank spaces just so that I can fit the whole function on screen and talk you through it one more time. So again, if we hit this guard statement, we don't pass the condition, guard won't let us pass, so it's going to execute the else condition. We're going to print out this statement, we return, and we're done with this function. But if the guard lets us through because it's true that the number of dice is greater than 1, then we skip the else clause and we keep on rolling through the rest of the function. Now let's try this out. Let's change our function call so that it has a 0 for number of dice, and we see cannot calculate roll of 0 dice. Nice! What if we make this a -3? Ooh, nice. Our error handling works for any value less than 1. Very good. And if we roll 1 dice, we see a single roll, no commas or spaces after it. And if I roll 5 dice, maybe I'll set these to 4-sided dice. We see 5 rolls, the values have commas and spaces between them. Mission accomplished. Now, if you were able to solve this before we learned about the guard statement, feel really good about your coding skills. Do a happy dance. That was a tough one. If you didn't get it, again, it was a harder one. Don't feel bad, new coder, but you should go back through this again until you can get the answer on your own and you understand how the answer works. Now I'm going to show you a few more examples on a series of slides, and it's a good idea to open up a playground and try out some of these small code examples. This is a great way to reinforce the concepts I'm demonstrating. Now, another hugely useful thing to be able to do is to write a function with a return value. Functions with return values send back results after their processing. So to write a function with a return value, when you define the function, just put an arrow after the closing parenthesis plus the type that you're returning. Then use the return statement inside the function to pass back a value that results from the function. Just make sure that the value that you're returning is the same type as the value after the arrows. So this function here returns a string. So if I call print with this function inside of parentheses, it returns back a string and I can print that string, like this greeting for the rock. Now this function here accepts an array of double temperature values and converts those to another array of doubles containing Celsius temperature values. And look what I'm doing here. In the function call, I'm passing in temperatures. This function gives me back a new double array, and I'm assigning that back, replacing the old value of temperatures with the new Celsius temperatures. It's totally okay to do that. Now here's a shorthand that you might see for functions that have return values. If a function has a return value and it only has one line that has an expression that results in a value of the same type to be returned, then you don't need the return statement. So this greet in Chinese function is the same as this one here on the right, but the one on the right is just one line, it returns a string, and the only line inside of it is a string, so we don't need the return keyword. I actually don't like this shorthand. I think it doesn't save you that much, and potentially it makes your code harder to read, but even Apple uses this shorthand sometime, so know that it exists because you might see this in code examples. Finally, you don't have to have one return statement on the last line of a function. You can have return statements from any branch of a function, like inside the different conditions of an if-else statement or the different cases in a switch case statement. Just make sure that every possibility has a return statement, otherwise Xcode will point out the error. Now let's enter a couple more examples of functions with return into a playground, and before I do this, I'm going to comment out all of my older code so I don't confuse the output with the new code I write. I'll put in a comment saying these are functions with return statements, and I'll print an empty string for a line feed, although I guess I don't need this since I just commented out all my code. And in an earlier example, we wrote code to get the average of an integer array of grades and return a double, which is the average of those grades. So now let's create a function that does the same thing. We'll say func average, and in parentheses, grades, colon, passing in brackets int. So that means we're passing in an array of integers, and then I'll draw an arrow after the last parenthesis, and we're going to pass back a double, which is an average of all of these grades. So just a single double value, open and close curlies. So to get an average, we need to total up our grades, and then we need to divide that total by the number of grades. So we need to create a total value to start off with. We'll say var total equals 0. Then we'll go through all of the grades in our array with for grade in grades, open and close curlies. In here, we want to add each individual grade to our total, so we can say total plus equals grade. That's the shorthand for total equals total plus grade. Then after we've gone through our loop, we have a total. So in my return statement, I'm going to calculate the average and return that value. So I'll say return, but remember, since total is an int and grade count will be an int, but we want to return a double, we need to type convert those two values before we divide them. So we'll say double, then in parentheses, pass in total, slash for divided by, double, in parentheses, passing in grades.count. This will give us back our double, so our grades now have a decimal in them. And then let's try this out with 3 students. We'll say var Michael grades equals, and in brackets, 40, 65, 70, and 68. Pam grades equals, in brackets, 95, 88, 72, and 87. And var Creed grades equals, and Creed is so enigmatic, 000, but a 94. Now, since average is going to return a double, then we can just go ahead and put that inside of anything that we want to print. Now, it's absolutely okay in Swift to return a function call in a string interp. So this is perfectly fine code. We can say print the string, Michael earned a string interp, and then in the string interp we'll call average, the function we just wrote, passing in the array, Michael grades, and this is going to return a double, but since it's inside of the string interp, then it'll print as part of our string. Now you can also put literals in here too, so we could say print Pam earned a string interp, and then when we call average here, I could just copy Pam's grades and paste them in here. I'm not using the variable Pam's grades that I created, but I wanted to show you can in fact pass in a literal or even an expression. Since this function accepts an array of ints, as long as you pass in something that evaluates to an array of ints, your function will accept that. And just to demonstrate, let's calculate Creed's grades on 2 lines. So first we'll create a constant with let Creed score equals average, and we'll pass in Creed grades. Then since we created a Creed score, we can say underneath this, print Creed earned a string interp Creed score. Then shift return to evaluate this. Michael got a 60.75, Pam got an 85.5, and Creed earned a 23.5. And just one more function with a return value. Let's write a function that returns their letter grade. So we'll say func final grades, let's pass in one parameter score, which is a double, and we're going to return a string. And in between the curlies, why don't we use a switch case statement to return the results? And so we'll say switch score, open and close curlies, and we can put in a range for our different cases in here. So I'm going to say case 90 ... 100, that's a closed range, colon, next line, return a string of just an A, only one character in there. Now notice any value between 90 and 100 inclusive is going to get an A. Then on the next line, we'll use a half open range, case 80 ... less than 90, colon, return the string B. So anything between an 80 up to but not including a 90 is going to get a B. Then case 70 ... less than 80, colon, return a C. Case 60 ... less than 70, colon, return a D. And for a default, colon, we'll return an F. Make sure that you've got two curlies to close out the switch and the function. I'll give myself a line feed with print empty string. Then we'll call print Michael earned a string interp. And now inside the string interp, let's make a function call inside of a function call. So we'll start off with final grades, and I'm going to pass in for my score a call to average grades, Michael grades. So average grade requires an array of ints. That's what I'm passing in here, which is Michael grades. This is going to give us back a double value. Final grades requires that double value, and it's going to give us back a string. So I wanted to show you that this was possible. We've actually nested three functions, one inside the other. So average passes a result back to final grades, which passes a result back to print. So there's only one line of code to do all this, but it's a really tough line of code to read. So pro tip, if you're ever faced with a choice between writing less code or writing code that's easier to read, it's almost always better to write code that's easier to read. Now for PAMs, we'll say let PAM score equals average grade PAM grades. Then we can just print out PAM earned a string interp, final grades score PAM score. And we already got Creed's grade in the example above, and we put that in a value called Creed score. So we can just say print Creed's final grade is a string interp, final grade score Creed score, then shift return. Michael earned a D, Pam earned a B, and Creed's final grade was an F. Ugh, better luck next time, Creed. So, after you funked out with big learning, we learned to define and call functions with no parameters, multiple parameters, and return values. We learned how to write functions with multiple return statements, and we learned the shorthand for removing return and one-line return functions. We also learned how to use the guard statement, and we used a switch case statement with ranges. In our next lesson, we'll apply some of this funky goodness in our You Are Awesome app. Feeling good about that big learning, Swifter? Drop a comment and let me know. And keep at it.